from the MIT MediaLab and in a group called Design Ecology. And I design mapping software. So this is a Google map, which is fairly rich, but I guess I'm really interested in how mapping is a narrative process, how you tell a story with maps. And I've been frustrated with the existing map technology for a number of reasons. These are the 5 kind of issues that I list and I keep in mind while I'm working. And I think that things like integrating live data is something that's relatively difficult on a web map like Google Maps. Affording a GPS to submit to it. And just making maps that are different from everyone else's maps that tell a different story, your own story. To solve these problems, I developed this software platform called Cartagen. And what it is an integrated reporting mechanism and a way to publish maps that are dramatically different from Google Maps. This one is drawn on like a brown paper background, and it has patterns, and it's kind of nice. There's a wiki.cartagen.org, so you can download it, and it takes about 5 minutes to get up and running with a map of anywhere in the world. To demonstrate how different it is, I made this map, which is a map of the entire world in the visual style of the classic computer game Warcraft 2. So as you can see, there's the Her Majesty's Treasury, Parliament, there's some kind of castle and a farm. And so you can, and you know, this is an Ignite presentation, so I can't scroll, but you can scroll in any direction as far as you want. As far as you want, and it will continue to draw the map in that style. So it's really like a lens through which to see the world. This is one that integrates real-time data. So this is Google News, recent articles that have been published. This is BBC News looking at specifically their articles, connecting the headquarters to every story that they've covered. So you can watch this, and news stories appear on the map in real time. This is one integrating sonar fish sensors, a project that Natalie Jermajenko is doing in the south tip of Manhattan. And the idea, when it's done, is that you'll be able to actually see fish moving in the river. This is based on OpenStreetMap data. A lot of the stuff I'm working on uses OpenStreetMap data, and it's fantastic. This one, we have some really hardcore mappers in Cambridge, Massachusetts, and they report the road condition, like how many potholes there are. So this is a one style sheet that just puts that on a map, and I think having this browser window open at the MBTA, where they are, I guess, in charge of that stuff would be great. I like working on smartphone platforms, and the iPhone is, of course, a really exciting platform to work on. We've done some of this, but really, like, I think when you look at OpenStreetMap's coverage, you get a sense of how difficult it is for some people in the world to be involved in this process and take advantage of geodata and geotechnologies. I think it's obviously getting better. Mikhail's work is like paramount in this process. But I think there's a lot of new techniques we can pioneer, and the other part of my research is trying out new methods, super low-cost methods. Luckily, we have this infrastructure already in place. This is in Kenya. These are a lot of antennas, and of course, in Kenya, like the cell phone ownership is, I think it's like over 90%. It's incredible. So in a sense, we have this active real-time sensor network already in place. People already own the phones. So how do you do this without a GPS? I think I've been working on some things that are a little bit like the walking papers, but one thing that I think has worked quite well for scenarios like disaster response is just string-based geocoding. So this is a project I did last year where we asked people in Manhattan to report when they saw wild animals, like rats, bats, pigeons, and you could report them just by saying pigeons in Union Square. And the Union Square was good enough. We centered it on Manhattan, so you might want to say Manhattan as well. But enough to get a latitude-longitude lock to within like a few meters. And you notice that even in rural parts of India, you can get a town which is not mentioned anywhere else on the internet. You can actually get a latitude-longitude lock on the center of that town just with one word. I didn't even say India, I just said Risera. So that process is pretty good for a village resolution. Obviously, you couldn't get an intersection in that town. And then, paper techniques, I think what Mikhail was talking about is great. And what I'm looking at is a way to print like an atlas that you could distribute for a region. And it would have unique codes for the entire Earth. There's an algorithm called a geohash, which generates a short code that describes every single location on the Earth. And the longer the code is, the more accurate it is. So to describe an area the size of this room is about 7 characters. And 1 meter square is about 9 characters. And these are just A through Z, 0 through 9. You can easily text that on an SMS phone. So that is, you look at the map to see where you are, because you know where you are. It's just a problem expressing that to a computer, and then you type the code in. So we're experimenting with that. And then, of course, you can receive these also on a SMS phone and view them on your laptop in the field, even if you don't have an internet connection. That's the other good part about Cartagen, is that it stores everything in a vector format and draws it, so you can actually keep an entire region on your laptop without an internet connection. And I guess to wrap up, celestial navigation is something I've been reading a lot about, not just because I'm like have a nerdy interest in it, but I really do think, and I'm prototyping this, I was working on it yesterday, if you can use a camera phone and line it up with a horizon, figure out where the sun is, measure that angle, you can use traditional celestial navigation techniques to find your latitude and longitude without a GPS. And you know, the number of phones out there, there are 4 billion phone users worldwide, a lot of those have a camera in them. So I think that's another way to kind of extend the reach of these technologies. Thanks very much.